Hello folks, welcome back. I'm your host Amit, and today we are going to discuss the move zeros problem. Without any delay, let's get into the problem. So the problem here states that given an integer array nums, we need to move all zeros to the end of it while maintaining the relative order of the non-zero elements. We should do it without making a copy, and we need to optimize the total number of operations that are done. So we should be able to do with two-pointer approach. So let's discuss how that two-pointer approach works. So we would have a pointer pointing to a location where we want to insert. So if there is 0 and there is like another pointer which is just iterating through all of these elements. So that iterator would see if there is a 0, it would just skip. And if we want to insert something, then only our insert index would move forward. So we have two indexes. One is like two indices. One is insert index, which is propagating forward, and the another one is our iterator, and that iterator also keeps moving forward. Okay, so what this iterator would do, it would check like if there is a non-zero element, and if the insert position index, if that is not same as the iterator index, then we definitely would insert 0 at the position of the iterator and move that element to to this index position. Okay, so I think this approach should work, and we would need to iterate only once. Okay, with this understanding, let's try to solve this problem. So how would we go about it? So we would have insert index, and this insert index, we would start from 0, and yeah, there is at least one element in the constant which is given, and this is a valid integer. So what we would try to do here is we would start a loop, and we would iterate through all the numbers. We would start from 0 and goes to 0 and I less than nums dot length I plus plus. Okay, if I nums of I is not equal to 0 and I is not equal to insert index, in that case we would add num to that insert index. Okay, and if we insert that index here, we would increment our insert index. Okay, and if it is 0, we would just move forward, and at the end what we would do is whatever elements are there, they should also become 0. Okay, so how those elements would become 0, because we should also replace this nums I with those with zeros as well, right? Or so we may not do it because we need to minimize these operations. So we would again start a while loop or a for loop, and we would start from insert index, and insert index, we will start with insert index. Okay, so we have iterated till the last, and we have already incremented this insert index. So, and we would check if we have not reached the end of the array, and we'll do I plus plus, and here whatever indexes, whatever places are left, we would fill up with 0. Okay, great. I think this looks fine. Let's try to run it. So why we have created this separate for loop is because we don't want to manipulate these elements first to 0 and then to other element. So as stated here, like, can we minimize the total number of operations done? So in this way we would minimize the total number of operations. Let's try to submit it. Okay, we have a problem here. Okay, so this problem is like we are checking this extra condition to just not only check this, but still we need to increment this insert index. So instead of checking this condition here, we should check before this if these index are not seen, then only do this operation, otherwise skip this operation as well. Okay, now it looks fine. This is successful. Let's try to submit it. Okay, we are accepted, and we are able to run in 4 milliseconds, which is nearly 60% percentile. Okay, see you folks. See you in the next one.